Intel spent more chasing smartphones than Tesla spent building the first electric cars. And what did they get? Zero market share. But here's what makes this story even crazier. Intel didn't just miss mobile phones, they missed everything that came after. Tablets, smartwatches, IoT devices, automotive chips, AI processors, an entire universe of computing that now powers our daily lives. Today, there's $5 trillion worth of mobile-first computing in the world. Intel powers almost none of it. So how does the world's most powerful chip maker miss not just one wave, but the entire ocean of new computing? The answer starts with a series of small decisions that led to one catastrophic call, a call that changed everything. But to understand how spectacularly Intel failed, you first need to understand just how completely they dominated. It's the early 2000s and Intel isn't just successful. They own computing. 8 out of 10 computers run Intel chips. That little Intel Inside sticker, it's on every laptop, every desktop, everywhere. It's not just marketing, it's a guarantee of what's powering your digital life. This was Intel's world. The personal computer revolution they helped create was in full swing. Millions of people were buying their first computers, getting online, discovering email and the early internet. Wall Street treated them like gods. Stock price soared year after year. Money poured in by the billions. Intel's market cap hit over $500 billion at its peak, making it one of the most valuable companies on earth. Inside Intel, confidence was sky high. They weren't just a chip company, they were the chip company. Industry awards, best workplace recognition. The smartest engineers in Silicon Valley all wanted to work there. Andy Grove, their legendary boss, had one rule that became Silicon Valley gospel. Only the paranoid survive. For decades, that paranoia kept Intel ahead of everyone. Grove even wrote a best-selling book about it. The core idea: successful companies must constantly watch for strategic inflection points. Moments when the rules of the game change completely. They didn't just design chips. They made them better than anyone else. Smaller transistors, faster speeds, cutting-edge factories that cost billions and took years to build. For over 3 decades, Intel had religiously followed Moore's law, doubling the number of transistors on a chip every 2 years. It wasn't just a prediction anymore. It was Intel's roadmap to domination. Competitors couldn't keep up. AMD was constantly playing catch-up. VIA was a distant third. Intel had created a technology moat so deep that crossing it seemed impossible. But success has a way of making you comfortable. And by 2005, Intel was feeling pretty damn comfortable. They'd won the PC war. They'd crushed competition. Their next challenge was just making faster processors for bigger computers. The future looked like more of the same, but better. They had no idea what was coming. No idea that their biggest competitor would soon fit in your pocket. No idea that the most important computing platform of the next 20 years was already being designed in secret labs across Silicon Valley. And they definitely had no idea that they were about to make the most expensive series of mistakes in business history. The clues were right there. Small devices getting smarter, phones trying to do computer things, a new world brewing, and companies started knocking on Intel's door with weird requests. Chips for tiny gadgets, processors for mobile devices. Intel kept saying no. Not enough profit, market's too small, we're a serious chip company. So these companies went somewhere else, to competitors making chips based on something called ARM architecture. Intel's x86 processors were built for performance. Powerful, but they ran hot and drained batteries fast. ARM chips were built for efficiency. They sip power like an economy car sips gas. Here's where it gets crazy. Intel owned a division making ARM chips, X-scale, perfect for mobile devices. Know what they did? They sold it, $600 million, to a company called Marvell. Marvell immediately started winning contracts for smartphones and tablets, the exact market Intel just walked away from. Intel sold their ticket to the mobile revolution for pocket change. Why? Because ARM chips were low margin. Intel was used to fat profits from computer processors. PC processors had 60% profit margins. Mobile chips, maybe 20%. Intel wanted the big money. That was mistake number one. But the biggest mistake was still coming. A phone call from California that would haunt Intel forever. A guy in a black turtleneck sits in a secret lab in Cupertino. It's not the gleaming Apple Park we know today. This is the old campus, smaller, scrappier, but buzzing with the energy of something revolutionary. Steve Jobs has a vision that sounds completely insane to most people in the tech industry. Put a computer in everyone's pocket, not just a better BlackBerry or a smarter Palm Pilot, a real computer with a real operating system, real applications, a device that makes carrying a laptop feel ridiculous. Remember what phones looked like in 2005? The Motorola Razr was the hot device. Thin, stylish, but it could barely send text messages. BlackBerry owned business users, but the screen was tiny and it could only really do email. Palm Treos tried to cram a desktop operating system into a phone, but they were slow, clunky, and crashed constantly. The user experience was terrible. Apps took forever to load. You needed a stylus to tap tiny buttons. Batteries died in a few hours. Web browsing was like watching paint dry. If paint took 3 minutes to load and then crashed. Jobs looked at all this and saw the problem clearly. These weren't phones trying to be computers. They were computers pretending to be phones. Everything was backwards. Inside Apple, the debate was intense. Should they build a better iPod that could make calls? Should they partner with a phone company? Should they build their own phone from scratch? The iPod had already proven Apple could build amazing mobile devices. By 2005, they'd sold 100 million iPods. People loved them. The interface was intuitive. The design was beautiful. The experience was seamless. But phones were different. Phones needed cellular radios, which meant dealing with carriers. They needed longer battery life, which meant efficient processors. They needed to handle voice calls, data, applications, all simultaneously. Jobs' team started working on prototypes. Some looked like iPods with phone capabilities. Others looked like tiny tablets. They experimented with physical keyboards, touchscreens, even projection displays. But they kept running into the same problem: the processor. Everything they wanted to do, smooth graphics, instant app launching, seamless multitasking, all-day battery life, required a processor that didn't exist. They needed something powerful enough to run a real operating system, but efficient enough to last all day in your pocket. Apple had 3 options: design their own processor, use an existing mobile processor, or convince the world's best processor company to build something custom just for Apple. So in 2005, Steve Jobs picked up the phone and made what might be the most important business call of the 21st century. The call went to Intel. "We're working on something that will change everything," Jobs said. "It's going to be the most important consumer electronics device ever created, and we want you to power it." Intel looked at the proposal. Apple was asking for a custom processor design, but Apple wanted to pay a certain price per chip. Intel calculated their costs: design, manufacturing, testing, support. Intel's analysis showed this would be barely profitable, maybe even a loss in the first few years. Apple was talking about maybe a few million units annually, not enough volume to justify a custom design program. Remember, Intel was used to selling hundreds of millions of PC processors at high margins. This Apple project looked small, risky, and unprofitable. And they said, no. Paul Otellini, Intel's CEO, explained the decision years later. They wanted to pay a price below our forecasted cost. Looking back, the volume was 100 times bigger than we expected. 100 times bigger. Apple was projecting 10 million units in the first year alone. Intel's team had assumed maybe 1 to 2 million units annually total. But even that doesn't capture the full scope of what Intel missed. They weren't just saying no to the iPhone. They were saying no to the entire smartphone revolution that would follow. They optimized for their existing business model instead of the future. It made perfect sense if you believed the world would always look like 2005. From Intel's perspective, this made sense. Why risk resources on an unproven mobile device when PC sales were still growing? Why accept low margins on a speculative project when high-margin server processors were printing money? Jobs didn't give up. He couldn't. Apple's entire future was riding on this device working. So he went to Intel's competitors. Companies making ARM chips, companies that said yes to the exact same deal Intel rejected. These companies understood something Intel missed. Volume changes everything. Even small margins become huge profits when you're selling billions of chips. More importantly, they understood that mobile wasn't just another computing platform. It was going to become computing. Samsung said yes. They agreed to customize an ARM processor specifically for Apple's secret device. Not because it was immediately profitable, but because they could see where this was heading. Today, Apple is going to reinvent the phone, the iPhone, the device Intel said no to, the device that would create a $1 trillion market. It wasn't just a hit, it was a revolution. 1 million sold in the first year, 100 million by year 4. And inside every single iPhone, an ARM processor made by Samsung, the same technology Intel threw away. While Apple used Samsung for the first iPhone, another company was positioning itself as the king of mobile processors, Qualcomm. Qualcomm cracked the code with something called system-on-a-chip design. They put everything a phone needs, processor, graphics, cellular modem, GPS, all on one tiny chip. You can imagine the meetings at Intel, the uncomfortable silences, the dawning realization of what they just missed. But it gets worse. Android phones explode onto the scene. Hundreds of models, billions of devices. Every single one powered by ARM chips. The smartphone market reaches 1.3 billion devices by 2013. Not one has Intel inside. Intel's share of the smartphone market? 0%. But Intel wasn't giving up. They were about to try the most expensive comeback in tech history, and it was going to be a disaster. Intel's solution was a chip called Atom. Small, efficient, mobile-ready, or so they thought. Here's the technical problem nobody talks about. Atom was still x86 architecture, the same family as Intel's big processors, just smaller. But smaller x86 wasn't the same as ARM. It still ran hotter. It still drained batteries faster. It was like putting a small V8 engine in a compact car. Thermal imaging tells a story. x86 phones ran noticeably hotter than ARM phones. In a device you hold all day, that matters. Making things worse, Atom wasn't even designed for phones. It was made for weird gadgets called mobile internet devices. Instead, Atom ended up in netbooks. Remember those? Cheap, slow, tiny laptops that everyone bought for 5 minutes then shoved in a drawer. While Intel celebrated selling netbooks to college students, Qualcomm was building a $35 billion empire from smartphone processors. Think about the irony here. Intel invented the microprocessor, but they missed the biggest processor market in history. Intel faced another invisible problem: software. Every mobile app was written for ARM processors. Every development tool assumed ARM. This created a vicious cycle. Developers didn't optimize for Intel because there were no Intel phones. Device makers didn't use Intel because apps ran poorly. By 2014, Intel was getting desperate, and what they did next broke every rule of business. But Intel had an even bigger problem, something they completely underestimated. Patents building cellular modems wasn't just about engineering. It was about navigating a maze of 140,000 patents owned by Qualcomm, Ericsson, and other companies. Every feature in a modern phone, from basic calling to 4G data, was covered by multiple patents, and Qualcomm owned most of them. Qualcomm built a patent fortress around cellular technology. Intel showed up to the castle without a key. That's why Intel spent $1.4 billion buying Infineon's wireless division in 2011. They weren't just buying technology, They were buying patent licenses and engineers who understood cellular. A former Intel modem engineer explains the nightmare. Every LTE feature we wanted to add, we had to check. Do we have the rights to this? Usually we didn't. Even when Intel had working modems, device makers had to pay patent licensing fees, up to $20 per phone, just to use cellular technology. You can't compete when your competitor owns the rules of the game. This kept Intel perpetually behind. When Qualcomm launched advanced LTE, Intel was stuck with basic 3G. When Qualcomm moved to 5G, Intel was still perfecting 4G. Intel wasn't just fighting a technology war, they were fighting a patent war they'd started too late to win. Intel decided to buy their way into mobile. Literally. They called it contra revenue. You can't make this stuff up. Intel was paying companies to use their chips. Here's how desperate it got. Intel paid Asus $15 per tablet to choose their processors. Think about that. The bribe cost more than the actual chip. The math is staggering. Intel lost $4,000 every single second for 2 straight years chasing mobile. 4,000. Every second. Quarter after quarter of billion-dollar losses. Intel's mobile division was burning cash faster than a rocket launch. The most expensive market share buy in semiconductor history. It worked temporarily. Intel hit their volume targets. But nobody actually wanted Intel tablets. Imagine paying people to be your friend, and even then they don't really like you. Consumer surveys told the brutal truth. Even with massive subsidies, people preferred ARM tablets 85% to 15%. And then came 2016, the year Intel finally admitted defeat. But Intel's problems went deeper than mobile. They were about to lose the one thing that had kept them on top for decades, their manufacturing advantage. For 50 years, Intel had followed Moore's law, doubling transistor density every 2 years. It made them the world's most advanced chip manufacturer. But by 2014, TSMC was shipping 16-nanometer chips, while Intel was still struggling with their 14-nanometer process. Think about that. Intel, the company that invented advanced chip manufacturing, was falling behind. Intel made a crucial mistake. They hesitated to invest in extreme ultraviolet lithography, EUV machines that cost $200 million each, but were essential for the smallest transistors. A former Intel engineer explains, "We thought we could skip EUV and use older techniques. We were wrong. It set us back 5 years. Intel's 10-nanometer process was supposed to launch in 2015. It didn't reach high volume until 2019, 4 years late. While Intel struggled with 10 nanometers, AMD partnered with TSMC and leapfrogged to 7-nanometer chips. Suddenly, AMD processors were faster and more efficient than Intel's. You can't make this up. Intel, the manufacturing king, was getting beaten by a competitor using someone else's factories. AMD didn't just win back consumer PCs, they took 25% of Intel's most profitable business, server processors. Intel's manufacturing crisis was directly connected to their mobile failure. While they were distracted burning billions on tablets, TSMC was perfecting the processes that would power the future. Intel canceled Broxton, canceled Sophia, their last best hope for smartphone processors. A former Intel engineer remembers, "We knew it was over when they canceled Broxton. Years of work just gone. After more than 10 years, after burning billions, Intel officially quit mobile. ARM still owned 99% of smartphones. Intel had 0. But Intel's mobile failure wasn't their only missed opportunity. Remember 2005? The same year they said no to Apple? Intel also passed on buying NVIDIA for $20 billion. Pat Gelsinger later admitted, "We killed the one that would have made all the difference in the world," referring to Larrabee, Intel's canceled graphics project. Today, NVIDIA is worth $3.6 trillion. They define artificial intelligence. Intel? They're barely relevant in AI. Here's the kicker. Instead of investing in mobile, graphics, or new technology, Intel spent $128 billion buying back their own stock. They chose to prop up share prices instead of building the future. Apple never forgot that rejection, and in 2020, they delivered the ultimate revenge, the M1 chip, Apple's own processor for Mac computers, built on ARM architecture. You can't make this up. Apple used the same technology Intel threw away to build the chip that would destroy Intel laptops. This didn't happen overnight. Apple had been building this team for over a decade. They bought chip company TSMC in 2008, then raided Intel, hiring over 1,000 engineers with massive signing bonuses. The M1 didn't just compete with Intel, it obliterated them. Double the performance. 15,000 Intel workers lost their jobs in 2024. The company suspended its dividend for the first time in 32 years. Pat Gelsinger, Intel's current CEO, called it the most substantial restructuring of Intel since the memory microprocessor transition 4 decades ago. Engineers who spent careers building Atom processors watched their projects get canceled. Managers who made decisions that seemed reasonable at the time now live with the consequences. Paul Otellini, who said no to Steve Jobs, clearly felt the weight of that decision for the rest of his life. Today, Intel is trying to become a foundry, making chips for other companies, including competitors. But they're losing $7.4 billion annually in the process. Industry analyst Patrick Moorhead explains the fundamental problem. Why would Apple trust Intel to make their chips when Intel might prioritize their own products? The US government is trying to help with the CHIPS Act, $52 billion to bring advanced manufacturing back to America. Intel is getting a big chunk of that money. But building fabs is the easy part. Building trust? That takes decades. Most people don't know this story. They just know their phones work and their laptops are getting better. But Intel's choices held back an entire generation of devices. Years of hot laptops, dead batteries, and slow performance that didn't have to happen. Intel's mobile failure created an unexpected geopolitical problem. Taiwan became the center of the semiconductor universe. Not just TSMC, but hundreds of suppliers, equipment makers, and specialized manufacturers all clustered around Taiwan. 90% of the world's most advanced chips come from one island. When the US-China tech war began, this concentration became a strategic vulnerability. Suddenly, Intel's all-American manufacturing didn't look so outdated. It looked strategically vital. But Intel's story isn't unique. It's a pattern that repeats throughout business history. Step 1. Dominate your market. Kodak owned photography, Blockbuster owned video rental, Nokia owned mobile phones. Step 2. Get comfortable. Success breeds confidence, confidence breeds complacency. Step 3. New technology appears. Step 4. Dismiss it. Too small, wrong margins, not profitable enough. Step 5. Technology explodes. The toy becomes the mainstream. Step 6. Panic and try to catch up. Step 7. Too late. Harvard's Clayton Christensen predicted this in The Innovator's Dilemma. The very decision-making processes that make companies successful are the same ones that reject disruptive technologies. Andy Grove's warning proved prophetic. Success breeds complacency. Complacency breeds failure. Only the paranoid survive. One man saw the future clearly. Steve Jobs knew phones would become computers. He knew efficiency would beat raw performance. He offered Intel a partnership in that future. Intel chose the past, and it cost them everything. Five billion people carry smartphones today. Not one of them has Intel inside. All because, once upon a time, Intel said no. Intel is fighting to matter again. Pat Gelsinger knows the stakes. We have to execute flawlessly from here on out. They're spending $100 billion on new factories. But after 15 years of delays and broken promises, trust is the hardest thing to rebuild. The lesson? In technology, dominance is temporary. The future belongs to those who see it coming. Sometimes the most important meeting you'll ever have is with someone who thinks different. 5 billion smartphones, 0 Intel chips. One word changed everything. The next time someone offers you the future, say yes. If this video made you think, if it made you question why some companies own the future and others miss it, don't just sit there. Spread it. Share it with the friend who still swears by Intel, the one building a startup, the one betting on NVIDIA. Because the next time a trillion-dollar company fumbles the ball, you'll remember this moment. And if you want more stories that shake your brain like this, hit that button, you know which one. We're not chasing algorithms here. We're building a tribe of people who see the world differently. So join in.